Okay, so now that the recording is started, just make sure everything is all set. Okay, so today I'm going over compound inequalities, and this is something that you're going to see if you have to go on to college algebra. So just as a review, inequality symbols you have seen before. We've got less than or equal to, greater than or equal to, and it's important to know which symbol is which. You read them left to right. So whatever is on the left is symbol name, and then the thing on the right. This week, we are looking some at linear inequalities. And so we've already looked at linear equations. So they have equal signs and there's no exponents on the variables. Inequalities use the inequality symbols and there's still no exponents on the variables. So they're very similar to the equations that we studied when the first half of the class when we were solving for x, and we didn't have any like x squared stuff. And a compound inequality is where you have two of the symbols instead of one. So you've got two different inequalities and you're looking at them at the same time. So there are 4 different ways you can have compound inequalities with a combination of the less than and the less than or equal to symbols. And we always write them smallest to the largest. So you don't see the greater than or greater than equal to symbols when you see it written. You may get one in the steps or the process of solving, but your final answer will not have them. They're always going to be the less than or equal to. So we are going to be using set builder notation, and you need to be able to go from your inequality, your final answer in the inequality form, to the set builder notation, to what the graph would look like, and then what interval notation is. So this is just going to be used as a reference for us to take our inequality that we got at the end and then write it in the appropriate form. So when we're solving inequalities, we're using the same rules when you're solving anything for x. You can add on both sides, you can subtract on both sides, you can multiply on both sides, and you can divide on both sides. So same rules. There are just 2 extra things you have to think about. First is if you're multiplying or dividing by negative, the inequality flips direction. So it changes from like a less than to a greater than. So it just kind of takes a mirror image. And then the second thing is when you have a compound inequality where you have 2 symbols, instead of 2 sides, you now have 3 different sections. And so you still do, it's still like you do it on whatever you do on the left, you do on the right. Here you do it on the left, the middle, and the right. So it's still the same process. It's just that you've got 3 places where it's happening instead of 2. So these are all going to be compound inequalities going forward. We're going to solve them, graph the answer, and then write the solution in set builder notation and interval notation so that you can get used to going between the different forms. So on the left, we're going to start, we have 0 is less than k plus 7, which is less than 6. Now, when you're solving these inequalities, your goal is you always want to have your variable in the middle when it's a compound inequality. So our goal is to have some number, and then your symbol, and then your variable, and then your symbol, and then a number. So your variable needs to be in the middle. And you want it by itself in the middle. So instead of like maybe put it on the left or putting it on the right, we want it in the middle. So we have k plus 7 in the middle. We want just k. So we need to get rid of the plus 7, and we do that by subtracting 7. And we need to subtract 7 from 3 places. We're subtracting it from the left, we're subtracting it from the 7, and then we're subtracting it from the right. So with compound inequalities, you've got 3 things going on because you're working like 2 things at the same time. So 0 minus 7 is -7. Then we have less than k. And then 6 minus 7 is -1. And you need to make sure after you do this that your smaller number is on the left and then the bigger number is on the right. And if it's not, then we have to do a little bit of manipulation and just do a mirror image, kind of flip-flop it. But -7 is less than -1, so we're in the correct order. So that's our solution. Then when we graph it, the graph is saying that our answer for K is between -7 and -1. So I'm going to shade in between because our variable is in between. And then the less than symbol can be written with either open circles or parentheses, kind of depending on what you prefer. I'm going to do open circles here. So we put open circles at the endpoints because we are not including the -7 and the -1 because there's not, it's saying that we've got K is greater than -7, so it's not including it. And then we've got K is less than -1, but it's not including it because it doesn't have the line underneath. So if you have a less than or a greater than, you use open circles when you're graphing. And then when you turn it into interval notation, open circles become parentheses. So that's our graph. We've got our graph here. The next is to write the solution in both set builder notation and interval notation. So set builder notation is really easy. What you do is you take the inequality that you solved for, and we basically stick it into set notation. So we start with our curly brace, then we have our variable, then you have a vertical bar, and then your inequality that you solve for. And then you close it with a curly brace. So that's your set builder notation. And then interval notation comes from the graph. So if I read what I have shaded on the graph, I have a open circle at -7, and open circles are parentheses and they face where you're shading. So it's going to be a parenthesis facing to the right. And that's starting at -7. And then I'm shading until -1. And then I stop shading at -1. It's an open circle, so it's going to be a parenthesis and it faces where I'm shading. So the parenthesis is going to face to the left. That was not a great parenthesis. So that is your interval notation. So we solved, we graphed our solution, we took our solution and wrote it in interval notation and set builder notation. So let's take a look at the one on the right here. We've got -2 is less than or equal to P, +1 is less than 4. So first thing you want to do is get the P in the middle, because that's what we do when we have compound inequalities like this. So we have a +1 in the middle with the P. We want to get rid of that by doing -1. So I'm going to subtract 1, and I have to subtract it from everywhere if I can get my pen to actually work. So I'm subtracting it from the left, the middle, and the right. So -2 minus 1 is -3. Then I have a less than or equal to sign. I have my P, then I have my less than, and then 4 minus 1 is 3. And so after you solve, you make sure that your smallest number is on the left, the biggest number is on the right. So that is correct, or -3 is smaller than 3. And so this reads as -3 is less than or equal to P, which is less than 3. Or if you read it in two separate pieces, you have P is greater than or equal to -3, and it's less than 3. So it's in between those two numbers. So the easiest thing to do is just to go straight to set builder notation. So that's just, you have your curly brace, your variable P, your vertical bar, and then you write your solution that you got. And then you close it with your curly brace. So that is your set builder notation. To do interval notation, I always graph it first, and we're asked to graph this anyway. So I'm going to draw my number line. And we have -3 and 3 as our two numbers. And compound inequalities are always in between. That we're saying that our variable or answer is between -3 and 3. So I have to shade the area in between them. And then at -3, it's a less than or equal to, which is a solid dot because we can include -3. And at 3, it's a less than symbol. So that means it's not filled in. We're not including the endpoint. So that's an open circle. And so when you convert this to interval notation, you read it left to right. So on the left, I have -3. And a closed circle translates to a bracket facing where the shading is. So we have a bracket at -3. And then we stop shading when we hit 3. And that has an open circle, which translates to a parenthesis facing the shading. So that's going to be curving in towards the left. And then that's your interval notation. So here we've got our set builder notation. We have our graph. And then we have our interval notation. Now, normally you don't have to write all of this. You usually, depending on what the question is asking for, if it just says solve, you can give your inequality, your compound inequality, which is your answer. If it says set builder notation, then you're going to have to use the curly braces. If it asks for a graph, then you include your graph. And if it says interval notation, then you give it in that particular notation. So you have to make sure you're reading the problem to make sure you know what form it wants your answer, because there are different ways you can write your answer depending on what it's asking for. Are there any questions? Okay. So a couple more examples here. So these are also going to be one-step problems where you're solving like the other ones, but now we're going to be using the multiplication and division rules so you can see how that works. We're going to be doing the same thing, graphing, set builder notation, interval notation, all that. So we'll start with on the left. We have -24 is less than or equal to -2, which is less than negative or less than or equal to -20. So we want our variable in the middle. So I have a -2x. I need to get rid of the -2, and it's attached by multiplication. So we're going to divide to remove the -2. And so we are dividing 3 things because whatever we do it in the middle, and then we also have to do it on either side. And when you're dividing by a negative, your inequality symbols flip direction. And this is only when negatives are involved. So the less than or equal to becomes a greater than or equal to. And that's because we divided by a negative. So all of those are going to flip. And then you actually put in the numbers. So -24 divided by -2 is +12. Then I have my x, and then -20 divided by -2, that's a +10. So I had to divide by -2, and dividing by a negative causes the inequalities to flip. Now, when you solve and you get your variable in the middle, then we want to have the negative answer on the left, positive answer on the right, or not the negative on the left. What we do that we want the smaller number on the left, larger number on the right. And in this case, we have it opposite. The bigger numbers on the left and the smaller is on the right. To fix that, you do a mirror image. So when we do this mirror image, what happens is that the 10 and the 12 are going to swap directions, but then because we're doing a mirror image, our symbols are going to swap directions again. And so this happens when you're solving things with compound inequalities, is you have to kind of flip things. And every time things get flipped, like a sign or a direction, the inequalities change. They flip with it. So in order to have the 10 and the 12 swap places so they're in the correct order, we change the inequality symbols again. So you might say, well, that was kind of silly. Why did we do that? Well, sometimes you only need to flip it once. Sometimes you flip it two. So I can't just say, okay, I know I'm going to have to flip it again, so I'm going to skip it. You can't, because sometimes you don't have two flips. Sometimes you only have one flip. And the flips are for different reasons. So now we have it in the form that we want. We have the smaller number on the left, the larger number on the right. And when we read this, we have x is greater than or equal to 10 and less than or equal to 12. It's between 10 and 12. So our set builder notation, you have a curly brace, you have your variable x, you have your vertical bar, and then you put in your inequality symbol or your solution. And then you close it with a curly brace. And then we're going to graph it, because I always do that when I'm going to do interval notation. So on my graph, I put my two numbers that I have, 10 and 12. And our value for x is between them. And then I've got less than or equal to symbols for both. So those are going to be closed circles. So I'm going to make those closed circles right here. And then when you turn it into interval notation, all the closed circles turn into brackets. They're the square ones, the straight ones, and they face the shading. So I'm going to have a bracket at 10 facing to the right, and then a bracket at 12 facing to the left, because they're facing towards where you're shading. And that's your interval notation. Let's take a look at the one on the right. Again, we're going to have to divide by a negative here, because we have this -3 in front of the x in the middle. We want to get rid of that -3. It's attached by multiplication, so we're going to divide. And when we divide, the symbols are going to flip. So I need to divide everything by -3. And then that changes the directions of these two symbols when I do so. So I like to do those right away, flip them, and then I do the actual division. So -12 divided by -3 is a +4. And then in the middle I have x, and then 6 divided by -3 is a -2. Then once you have your x by itself, you consider, okay, do I have the smallest number on the left and the largest number on the right? And we don't, we have it in the other direction. So we have to flip-flop it again. So we're going to take the mirror image, and in order to flip where the -2 and the 4 are, we have to also flip the symbols. So the -2 and the 4 are going to swap places, but that's going to cause our symbols to reverse direction. So in order to do that flip, our symbols have to change direction. And then we have our x still in the middle. So we have -2 is less than x, and x is less than or equal to 4. Or another way to think of this is x is greater than -2 and less than 4. So it's in between those two values. So set builder notation, you have your curly brace, your variable x, your vertical bar, and then you stick your inequality in on the right side. And then you end it with a curly brace. Now I'm going to graph the answer here. So the numbers we have are -2 and 4. And we are between -2 and 4. That's x is literally between those two numbers. -2, the symbol that's sort of like next to the -2 is a less than, so that's going to be an open circle. And then at the 4, the symbol with the negative or with the 4 is a less than or equal to, and the equal to means it's a closed circle. So I've got an open circle and then a closed circle. When I convert this to interval notation at -2, The open circle is a parenthesis. It's going to fade to the right because that's where we're shading. And then we're going to stop at 4. And the closed circle is a bracket, and it's going to face to the left because that's where the shading is. So you're going to get a parenthesis -2, comma 4, and then a bracket. Are there any questions? Okay. Now we're going to be doing multiple steps. And so we have to do addition and subtraction. We've got lots of things going on here. So same directions. We've got -6 is less than or equal to 4a minus 2, which is less than or equal to 12. So just like when you're solving for x with an equation, you do your addition and subtraction before you do your multiplication and division. So we need to add 2 first before we do anything about the 4. So I need to get rid of that 2 that's in the middle because I want to get just the a by itself in the middle. And so I need to add 2 to the left and the right. So -6 plus 2 is -4. I have less than or equal to 4a is less than or equal to 14. Now, you don't change your inequalities if you're adding or subtracting. Next, we want to get rid of the 4. And so we need to divide by 4. Now it's positive. So if we're dividing by positive, we don't need to change anything. So we're not touching these symbols again. So that will give you a -1 is less than or equal to a, which is less than or equal to 14 divided by 4. That's going to give us a decimal. So we're going to just reduce that. And 14 over 4 reduces to 7 over 2 because I can divide the top and the bottom by 2. So now I have my a by itself, and we're just double checking that the number on the left is smaller than the number on the right, and that the symbols are all less than or equal to symbols. So they are. -1 is smaller than 7 over 2, and they're all less than or equal to symbols. So that is our solution. So we can put this in set builder notation, which is the curly brace. Our variable is a, vertical bar, and then our solution that we got. And then you close it with a curly brace. And we can graph our answer. So I'm going to have a number line, and I only care about my endpoints. So I put -1 and 7 over 2. And we're in between it. So we're shading. Our a is in between those numbers. At -1, we have a less than or equal to, which is a closed circle. And at 7 over 2, we have a less than or equal to, so that's also a closed circle. So we have 2 closed circles. So your drawing is just going to be closed circle, shading between the numbers, and then closed circle. And then interval notation is going to be taking those closed circles, translating them into brackets. So I'm going to have a bracket at -1, and they always face where you are shading. So that's -1, and then to 7 over 2, and that bracket is going to face the middle. So we've got our brackets facing towards the center, essentially. Okay, now we have -2 is less than 1/3 x minus 2, which is less than or equal to 2. So we're going to add or subtract to get rid of that -2 in the middle first. So I'm going to add 2 to get rid of that. And we have to do it to 3 things here. And so we're not changing any of the inequality symbols because we're not multiplying or dividing by negative. -2 plus 2 is 0. I keep accidentally hitting the color next to the white. There we go. And then it's less than 1/3 x, and then less than or equal to 4. And now we want to get rid of the 1/3. So we could divide both sides by 1/3 or multiply by the reciprocal. So if we multiply everything by 3, then that will get rid of that fraction. So we have to multiply 3 things by 3 in order to get rid of that fraction. And we're multiplying by positive, so we don't change the symbol. It's only when you're multiplying by a negative or dividing by negative. So 3 times 0 is 0. And then 3 times 1/3 is 1, so that leaves us x. And then 4 times 3 is 12. And we have our smallest number on the left, the larger number on the right, and all of our symbols are less than or equal to, so we're in the correct form. So then set builder notation is curly brace x, vertical bar, and then you write what you got for your solution. And then you kind of end your curly brace. Now I'm going to graph it so I can do the interval notation. And the 2 numbers that I have are 0 and 12, and I, have them in order. We are shading between 0 and 12 because our x is between 0 and 12. At 0, it's a less than symbol, which is an open circle. At 12, it's a less than or equal to, which is a solid circle. And when we translate this to interval notation, it's 0, an open circle is a parenthesis facing the right, because that's where we're shading. And then I have 12, and it's a bracket because it's a closed circle, and it's going to be facing to the left because that's where we're shading. And now here's our final example. We have distributing that needs to go on, and then we're going to add, subtract, do all that kind of stuff. So order of operations, when you're solving, you're simplifying, we always distribute before we do our adding and subtracting. So I need to multiply that 3 through the parentheses in the middle, and it's only going through the parentheses. So this is going to be 8 less than 3x, then 3 times 1 is 3. And then I have my -2 and less than or equal to 12. Then I've got 3 minus 2 that I can combine. 3 minus 2 is 1. So I can add those like terms. So I got x less than 3x plus 1, and then less than or equal to 12. Now I want to do my adding and subtracting to get rid of the +1. So I'm going to subtract 1 to undo that plus. We do it to both the left and the right in addition to the middle. And we are not switching any inequality symbols because we're subtracting, not multiplying. So that gives us 8 minus 1 is 7, less than 3x, which is less or equal to 12 minus 1 is 11. Then we need to get rid of the 3. So we need to divide by 3. So I have to do that to all 3 pieces. We don't change our inequality sign because it's a positive, not a negative that we're dividing by. And then these are just going to leave us fractions because we can't simplify these. So we get 7/3 is less than x, which is a less than or equal to 11/3. And so you need to verify 7/3 smaller than 11/3. Yes. So it's in the correct order. We've only got less than and less than or equal to signs here. So we have our correct form. So now we want to put it in set builder notation. So that's the curly brace, our variables x, vertical bar, and then our compound inequality. and then you close it with a curly brace. I'm going to graph the answer. So our two numbers are 7/3 and 11/3. And so we are shading in between them. The compound inequalities are always in between. 7/3 is a less than symbol, so that's going to be an open circle. 11/3 is less than or equal to, which is a closed circle. And then when we make this an interval notation, the open circle is a parenthesis facing the shading. And then the closed circle is a bracket facing the shading. So we got parenthesis, 7/3, comma, 11/3, and then bracket. So that in a nutshell are compound inequalities. They're very similar to solving regular inequalities. The only big major difference is that you've got something in the middle and you have to make sure that when you're done going through the math and you're doing it on all three parts, that your smallest number is on the left, the larger number is on the right. And if it's not, you might have to do like a mirror image to flip it in order to make it true. And then your answer is always going to be in between. And that's the thing with compound inequalities, is that you know your answer is between two pieces. So hopefully this was helpful, and I will talk to you guys later. Bye.